Hi, this is Sir Absolon of MathALAS channel, and welcome once again in another episode of Learning in Mathematics.
A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the following standard form: ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a must not be equal to 0. As we can see, there are three terms. The ax squared is the quadratic term, bx is the linear term, and c is the constant term. It is easy to spot quadratic equation if we see degree 2 in the equation. Now that we know what quadratic equation is, let's differentiate quadratic equation from linear equation. We know that quadratic equation is in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a must not be equal to 0. If a is equal to 0, then we no longer have a quadratic term, which will lead us to a linear equation, which is bx plus c equals to 0. Now, there are three things that you have to consider when differentiating linear equation from quadratic equation. One is the degree. Second is its solution or roots. And the third one is the graph. A linear equation is a first degree equation, meaning the exponent of the leading term is 1. On the other hand, for a quadratic equation, the highest exponent is 2. In terms of solution or roots, linear equation has one solution. On the other hand, quadratic equation has two roots or solutions. Take this example. X plus 8 equals 14 is an example of linear equation. Now, we have to find x that will satisfy the given equation. To solve for x, we have to add negative 8 in both sides of the equation, which will give us x equals 6. 6 is the only value that when you substitute to x will give you 14. On the other hand, if you have a quadratic equation which is x squared minus 9x plus 14 equals 0, and you try to factor this one and solve for x, you'll end up with the quantity of x minus 7 and x minus 2 equals 0. When you solve for x, using the zero product property, you'll end up with these equations. X minus 7 equals 0. When you look for x, it's equal to 7. For x minus 2 equals 0, when you look for the value of x is equal to 2. You see that for quadratic equation, there are two solutions. On the other hand, for linear equation, there is only one solution or root. When we talk about linear equation in two variables, the graph of linear equation is a straight line like this one. But when we talk about quadratic equation in two variables, the graph is a parabola like this one, like a U shape. Now that we know the difference between linear equation and quadratic equation, let's take a look at examples of quadratic equation. Example number 1. X squared minus 5x plus 6 equals 0. This is an example of quadratic equation because the highest exponent is 2, right? So, we get the values of a, b, and c. A is 1, as you can see, we have 1 here. B is negative 5. C is 6. So it's easy to identify the values of a, b, and c in the quadratic equation. Example number 2. Is this a quadratic equation? 5x plus 4 equals 19. Yes, it is a linear equation because the highest exponent of the variable x is 1. How about example number 3? 16x squared minus 9 equals 0. This is an example of quadratic equation where a is equal to 16, b is equal to 0, and c is equal to negative 9. This means that we don't have a linear term. So this quadratic equation is in the form of ax squared minus c equals 0. Let's take example number 4. Example number 4, 4x minus x squared equals 12. This is a quadratic equation, but not written in standard form. Take note that quadratic equation that is written in standard form should be in ax squared plus bx plus c equals 0. So let's rewrite this one in standard form. So we arrange the term in such a way the exponents are arranged in descending order. Now we have negative x squared plus 4x minus 12 equals 0. Take note that we added negative 12 to both sides of the equation. That's why on the right side of the equation, it's already 0. Now, this is not in standard form yet because the leading term, which is the x squared, is still negative. So we multiply negative 1. So negative 1 times the negative x squared is x squared. Negative 1 times the positive 4x is negative 4x. Negative 1 times negative 12 is positive 12, which is equal to 0. This time, this is now written in standard form, where a is equal to 1, b is equal to negative 4, and c is equal to 12 rather. Example number 5. 3x times the quantity of x plus 5 equals 21. Is this a quadratic equation? Yes, you're right. But again, this is not written in standard form. So we use the distributive property. We distribute 3x with x. So 3x times x is 3x squared. 3x times positive 5 is positive 15x equals 21. Now, we have to add both sides of the equation by negative 21. So when you add negative 21 to both sides of the equation, we'll have 3x squared plus 15x minus 21 equals 0. This time, it is now written in standard form. Now, our a is equal to 3, b is equal to 15, and c is equal to negative 21. Example number 6. The quantity of x minus 3 times x plus 4 equals 0. Again, this is still a quadratic equation but not written in standard form. So to do this and rewrite this one into standard form, we use the FOIL method. F stands for first, O stands for outer, I stands for inner, and L stands for last. So let's do the FOIL method. X times x is x squared. That's the first. X times 4 is actually 4x. That's outer. Negative 3 times x is negative 3x. That's inner. And negative 3 times positive 4 is negative 12, which is the last, equals 0. Now we combine like terms. The only terms that we can combine is the 4x and negative 3x. So, x squared. So when you combine 4x with negative 3x, we only have x, which is positive. Minus 12 equals 0. Now, this factored form, which is the x minus 3 times the quantity of x plus 4, is now written in standard form, which is x squared plus x minus 12 equals 0. Where a is equal to 1, b is equal to positive 1, and c is equal to negative 12. Pause the video and try these exercises. And don't forget to type your answers on the comment section. For letter A, you have to identify which of the following equations are quadratic and which are not. For letter B, write each quadratic equation in standard form, ax squared plus bx plus c equals 0, then identify the values of a, b, and c.